So hello everyone, welcome back to Code with Kerry, and today we are going to solve a very important question, which is the n queens problem. It's based on recursion as well as backtracking. So the problem statement says the n queens puzzle is the problem of placing n queens on an n cross n chessboard such that no two queens attack each other. Given an integer n, return all the distinct solutions to the n queens puzzle. You may return the answer in any order. So yeah, suppose let's try to understand the question. Suppose we have a n cross n chessboard over here. So there are three rules which we have to follow. That there can only be one queen in a row, only one queen in one column, and no two queens and shall attack each other. So just to make you understand what does the three rules stand for, here the first one, it says that there can only be one queen in one row. Means if I keep a queen here, suppose, then I can't keep another queen here, here, or here. Then second says that there can only be one queen in one column. Means if I keep a queen here, then I can't keep another queen here, here, or here. So this is how it goes. And then the last condition which says that no two queens shall attack each other. Like suppose if I queen here, if I keep a queen here, then as you can see these two queens are attacking each other, right? So this is also not applicable. So we have to find a solution where none of the queens attack each other, and we need to have one queen in every row and every column. Take an example of a 4x4 chessboard to solve this problem. So this is the 4x4 chessboard we have over here. So now if I try to put a queen on the first column itself, so I have four options. I can place the queen here, or I can place the queen here, here, or here. So these are the four options I have where I can place the queen. So now if I take the first case here, over here, so if I place the queen on the 0th index, going by 0 index, so if I put it here, I can't put another queen in this whole row. I can't put another queen in this whole column, and also diagonally. Because if I put anything diagonally, then the two queens will attack each other. So now if I try to put a queen on the second column, what are the options we have? We only have these two options. I can either place the queen here, or I can either place the queen here. I can't place them here or here. So yeah, let's see. So these are the two options we had. So now if we consider the first option, so after placing the queen here, can I place a queen here? No, I can't, because as you can see, this is coming in contact with this queen. Can I place it here? No, I can't. Can I place it here? No, definitely not, because of this. Can I place it here? No, I can't, because of diagonally attacking each other. So as you can see, there's no possible solution out of placing the queen here. So what we'll do is we'll backtrack. And while backtracking, we need to remember one thing, that we have to remove the q which we inserted here. So now going to the second option which we had, where we kept the q here. So now putting a queen in third column, can we place a queen here? No, I can't, because of this queen. Can I place it here? Yes, I definitely can. But now to put it here, can I place it here? No, I can't. Can I place it here? No, I can't. Can I place it here? No, I definitely can't, because of this being diagonally. Can I place it here? No, I can't, because there's already one queen in this row. So as you can see, there's no possible solution out of this option also. So what we'll do is we'll again backtrack. And while backtracking, we need to remember, we need to remove the q which we inserted. So now there's no other possible option out of this q placing right here. What we'll do is we'll backtrack from here. And while backtracking, just remember that remove the q. So now let's try for this first index. Like let's try to put the q on the first index. So if I put it here, what are the options do we have? If I put it over here, the options I have is I can put it. Can I put it over here? No, I can't. Can I put it over here? No, I can't. Can I put it over here? No. Can I put it over here? Yes, definitely. So now once I put it here, now let's go to column 3. Can I put a queen here on the first row itself? Yes, I definitely can. Now going for the fourth column, where can I put the queen? Can I put it here? No, I can't. Can I put it here? No, I can't. Can I put it here? Yes, I can. So yeah, we have the queen here. Now since this is the solution we have, so we have got one solution. So after getting the solution, what we'll do is we need to find all the possible solutions, right? So what I'll do is we'll backtrack from here. So before doing that, once we have got the solution, I'll make sure we store it in some vector or queue. So yeah, let's backtrack from here. Make sure you remove the queue. Backtrack again from here, remove queue, and then let's backtrack again from here. We're removing queue. Now let's go for the third option where we put the queue on the second index. So likewise, you have to do it for this case also and also for this case. So after doing all the cases, these are the two possible solutions which we have. So now let's try to code it. Let's try to code this problem now. First of all, what I'll do is I'll make a 2D vector, which will be our answer, right? Which will be our answer, the final answer. And then I'll make a board of size n. Then I'll make a uh, string s of size n, and it will be filled with zeros. Or should I say, not zeros exactly, but dots as of now. Okay, so let me just write this and I'll explain it to you. So what is happening here is, what I'm trying to make is, we are making a vector. We are making a vector which consists of each element of vector will be a string of size n. So are you getting it? It's like just like a 2D vector, but it will basically be a string. So just like if you have heard of adjacency lists, so it's similar, kind of similar to that. Now, okay, so now let me write the solve function. Void solve. What I'll pass is I'll pass this ans, our final answer. Also make sure we give the reference because we are making changes in the original uh, vector itself. We are passing the board. Also here also reference. And one more thing we'll be passing is int n, and another thing int column. So now before writing the base case here, base case, before writing the base case, because we'll be doing this by recursion, so I just want to explain about how we'll be going through. So first we'll traverse to the whole row for int I. Let us name it row. Row is less than n, and row plus plus. What are we doing? If is save. This is a function which we will be writing later. So I'll show it to you later. We'll pass in row, column, also n. So if it's safe to to put the queen over there, means there's no queen in the same row in the same column, or there's no queen attacking at that position, then what we'll do is we will put the queen there. So board of row and column will be equals to q. Now we'll again send a recursion for the next column. So what are the parameters for our solution? Solve ans board and n and column. Yep, that's it. And while backtracking, we need to make sure that we remove the queue. Okay, so yeah, that's it. This should be a solve function. But here also one more thing, that once we reach like if our column is equals to n, we'll like push back. It means we have the answer, right? So we'll just ans dot push back board, and we'll just return from here. So we have this solve function ready. Uh, so now we have to write this is safe function, right? This is the function we are writing. So void is safe. What are the parameters we are passing here? Board. Also here you don't need to pass the reference. because we aren't making any changes there. So yeah, int column and end. So before doing anything, I'll just store this row and column in a temporary variables. Temp row will be equals to our row, and int temp column will be our column, right? So now while column is greater than or is equals to 0 and row is greater than or is equals to 0, what we will do is we'll check if there's any other queen over there. If board of row or column is equals to q, then we have to return false. Else row minus minus and column minus minus. So this is one case. Now we have to, this is diagonally going upward, and this is diagonally this will be the straight line going backwards. So while column is greater than or equals to 0, oh my god, yeah. I'll just copy this right here and I'll just paste it. So the only thing we hear is column, and one more kind of similar to this here. Column should be greater than or equals, and row should be less than n. So return false, row plus plus. So I think that should be it. We'll call the solve function here. Solve of what are the parameters we had to pass. Ans board column will be 0 and int will be n. So yep, that is it, and return ans. I hope it runs successfully. We have error. It says is safe is not should not return a value. It says, oh, it's because this should be boolean. Uh, does not return a value in all control paths. It says, oh, return false, else return true. That's one more thing I forgot. Yeah, I think it's because of well, I guess, oh yeah, we forgot to increment the column. So yeah, this is one. Also, yeah, we are updating the row and column here, right? So we need to move them back to the original values also. That's what our main reason was to use these temporary variables. That I forgot. Okay, what more? Anything else? Uh, oh yeah, we are passing n here and then column, right? So I'm passing n here later, and so I should pass here n and then column. Yeah, I think that should be it.